So for this last section, or I'm sorry, for this next section, you need to find the complex zeros in exact simplest form, um, algebraically or with technology. So here we go. H of x is 9x squared minus 6x plus 1. If you refer back to that sheet, notice you have standard form, and to find the zeros, set to 0, then either complete the square or use the quadratic formula. If you watched my last video, number 17, it might have been somewhat torturous because I went through the entire completing the square process on this ugly looking function, where now thinking about it again, I probably should have just used the quadratic formula. But in any case, check out number 17. I did the completing the square process to find the zeros. It definitely took a little bit of time, but well worth the review. I leave it to you to do the quadratic formula. But we're no longer on number 17, we're on number 18. So this time I will absolutely use the quadratic formula for this 9x squared minus 6x plus 1. And what can I conclude about the x-intercepts? And then we'll double check it with technology. So here we go. So definition of 0 is an input value that outputs a 0. So to solve this equation, we can use the trusty quadratic formula to remind ourselves it's the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all that divided by 2 times a. So the solutions to this equation, the zeros are, I'll take the opposite of b, 6, since our b is negative 6, plus and minus b value squared. Negative 6 squared is 36, minus 4 times a times c. 4 times 9 is 36, times 1 is 36. Well, that's strange, or is it? All over 2a, 2 times 9. Alright, so I'm going to work horizontally here. 6 plus and minus the square root of, sorry, my dog just jumped on my lap. Moving on, 6 plus or minus the square root of 0, all over 18. So what are my zeros here? Well, 6 plus or minus nothing. Well, that's obnoxious. That's just, in either case, going to be nothing over 0. So I only have 1 0, 6/18, apparently, which can be simplified as 1/3. That's it. Which might seem strange, but we did investigate this in class. This did come up in at least a couple examples. So think about what that means on the graph. If you're only 0, if you only have one real 0, let's think about the cases that we can have. We could have a parabola. Our a value is positive, so it's going to open up. So if I can draw a parabola that opens up, I guess I can draw a parabola that has no zeros, which would mean the zeros, I lied, no real zeros. So these would have two complex solutions, two complex zeros. I could have a graph that, I don't know, maybe goes like this, such that it intersects the x-axis in two places, which would mean I have two real zeros. What if I only had 1 0? What does that imply? Can you think about what the parabola would look like? Well, we have one totally above, one that's intersecting twice. I think I got it. What about something like this? Oh, I could probably draw that a little bit better, so I will. Let me zoom in for a quick second. What about a parabola whose turning point is right on the x-axis? think that would imply 1, 0. Yes, this is one real 0. We actually call it a repeated 0. Oops, I spelled that wrong. Repeated. That's more than you need to know for right now. We'll investigate that in quarter 2 more. But the repeatedness comes from that we're adding 0 and subtracted 0. So it really just has no effect. This value 1/3 is a repeated 0, which implies the turning point is right on the x-axis. And that's all there is to it. Alright, so that can happen. And that's what it means graphically. If you actually did go through and graph this, here's the function 9x squared minus 6x plus 1, and what do you know, the turning point is on the x-axis. And again, not a big fan of this, but that was what we found. When you input 1/3, it outputs a 0. For those who didn't know, that 1/3 is approximately, really should be an approximately symbol here, 33 hundredths or 333 thousandths. That's it. Right, so there you have it. Putting all the pieces together. We have standard form to find the zeros. We can use the quadratic formula. In this particular case, we ended up with a repeated 0, which implies graphically that the vertex is right on the x-axis. That vertex, 1/3, 0, that is the vertex. And in this particular case, this special case, 1/3 is also the 0 of the function. Interesting indeed. More to come on that in a future unit. So good luck. If you have any questions, please feel free to email me.